Hi everyone. Our today's topic is component design for web apps. Component design for web application. Now we are going to learn about uh, how we are going to perform the design for web applications. Okay, this is about designing of web applications. Right. First of all, we will see what is web application component. What web application component includes? Okay, it is a web application component is a cohesive function. It is a cohesive function that manipulates the content and provide computational functions or data processing functions for the end users. Okay, what is the web application component here? Web application component is a cohesive function. What this cohesive function includes? Okay, it is a collection of the operations and also some attributes. What is the cohesive function here? Cohesive function is a it's a collection of attributes and its operations to perform some particular task. Clear? Right. So those attributes and those operations are used to manipulate the content, are used to manipulate the content of a project. Okay, or otherwise they may be provide some computational functions. They may be used for some kind of functions, okay, calculations, and will get results accordingly, right? And some data processing functions. Through that, okay, we may retrieve the data whichever resides in a application, isn't it? This kind of operations are performed by these cohesive function. Cohesive function is a encapsulated class, which means a class. It may have some uh, what attributes and related operations, right? So it is a one definition related to a web application component here. And also, if the second definition is web application component is a cohesive package of content design and functionality design that provides end users with some required capability. Okay, what it is? It is a cohesive package, not only a single class. It may be a multiple number of classes. It may be a multiple number of classes data may called web application component here. Okay, it includes this component level designing of a web app includes the elements of content design and functional design. It may includes a content design and a functional design here. It's collection of both. Okay, let us see one by one what is content design and what is functional design, right? Right. Content design for web apps. Content design for web apps is it focuses on content objects. This content design is focuses on content objects and how they may be packed for presentation to a web application. How those are all these content objects, how those are packed for presentation of web applications to the end user, right? So for example, if we take one example here, that example is a safe home assurance. Safe home assurance example. So what are the content objects under safe home application? Okay, here we are going to define some of the what potential content components related to a safe home applications here. Those are the content objects are, the first one is sensors and video cameras. Okay, whatever the sensors and video cameras whichever used for, okay, what capturing the data in a safe home application. So those two are coming under a content objects along with the collection of thumbnail videos, along with the collection of thumbnail videos and also streaming videos, and also streaming videos. These are all the contents. These are all the contents which is recorded by either sensors or video cameras for safe home application, isn't it? Okay, these will capture the data or content related to this particular object. Each of these components can be separately named and manipulated as a package. Okay, these above whatever we have discussing, some thumbnails or some streaming videos, so everything would be separately named. This is day 1 video, day 2 video, day 3 video, like that, and we saved. Okay, we have saved by using some packages or folders. Okay, day one all cameras information, day 2 all cameras information, like this. Here we are going to save accordingly. Okay, those are all called the contents. How we are going to design these contents for web applications, right? This is the content design for web application. If we'll see, the second one is a functional. What it is? Functional design for web application, right? Under this we are going to learn, so how the functions, okay, how the modern web applications deliver increasingly sophisticated processing functions, right? First of all, they would localize the processing, localized processing to generate content and navigation capability in a dynamic process. Okay, here we need to perform some localized processing to generate the content. Okay, first of all, it would localize the processing to generate the content, whatever the content we want to generate through the sensors or through the video cameras or to process that thing. Okay, whatever the sensors are generated the data, we need to process that information, isn't it? So that's why here we are going to use some localized processing techniques. Coming to the second one, okay, here we are going to provide, suppose if the data has some computational functions, okay, suppose the data has some the data needs to perform any kind of mathematical functions, okay, then we need to use some appropriate domain for performing these kind of computations, or otherwise that the data needs some data processing, right? In such a case we need to use some, okay, what data processing units, we need to include some data processing units. That is the second point. Coming to third point, here we are going to use some databases, provide some sophisticated database query and access. What we are going to provide, suppose that particular customer or end user is searching for some kind of video, whether it is available or not. Okay, suppose if it is available, it should be retrieved from the database. So how the customer is going to search? Here we need to provide some like search tab or something to interact with a storage unit. Okay, to interact with our databases, isn't it? So this kind of functions we need to include at this design. And after that, here you need to establish some data interfaces. Data interfaces, how we are going to, okay, interact with that particular functions. Okay, functions of that, not only single functions, if that has internal functions, or something. So how we are going to interact with that functions? For that we need to provide some interfaces. By providing some input to that particular interfaces, we are going to interact with that particular functions here. Like that, we need to design some functions related to a web app, isn't it? So in functional designing, in the sense, here we are going to develop a particular action related to a, okay, input, or based on that particular content whatever we have gathered there. So we need to perform some kind of function. That function may be it may be a computational function, which means it may be a mathematical function, or it may be a data processing function, or it may be a searching function. Okay, whatever it is, we need to get ready one design to perform some kind of tasks related to that particular function there. Okay, this is called functional designs for web apps. And also, if we want to achieve this, if we want to achieve this, okay, here we need to go for some conventional softwares. We need to learn some conventional softwares here if we want to achieve these functions. Okay, so what are the conventional softwares here? This is the designing conventional components. We want to achieve the functional designing, then we need to go through some conventional components design. So what is this conventional components design, and what we have to do here in the sense? Okay, first of all, here we are going to develop or design a processing logic. What we need to do here? First, we need to build or design some processing logic for basic principles of algorithm design and also for structured programming. Right, we need to develop some processing logic. And in second step, here we are going to design some data structures. We are going to design for data structures here. This processing logic for which purpose? This processing logic for which kind of computations you are performing at that particular step? Which kind of mathematical functions you are going to perform at that step? That is called a processing logic. Okay, not only that, computation, it may be a logical thing, it may be a logical condition, or it may be some any kind of computation. Okay, it's arithmetic computation, it may be or it may be a logical computation, or any kind of computation it is. If you want to, okay, perform a computational work, then you need to write some logic. You should implement some logic there itself to fulfill the computation to get some result there, right? So that's why first of all you need to design some process logic here. At second step, you need to design some data structures. What is the need of data structures? Data structures here we are using for storing some kind of data related to that particular application. Through these data structures only we can achieve the database concepts, which means storing concepts. How we are going to store the data into that databases, and how we are going to retrieve those data from the databases, that can be achieved through data structures only. Coming to the last one is designing of interfaces. Designing of interfaces. These interfaces are helped us to interact with one function with another function, isn't it? So you need to establish these three in conventional designing. Based on these 3 points only, okay, we can meet the goals of functional designing, right? And also, if we'll learn about these conventional components in detail, how we are going to process the logic, okay, how we are going to process the logic, what is the data structures, and how interfaces are helped. Like that, if you want to learn in detail about this conventional designing, okay, uh, then we would see the next slides here, right? First one is algorithm design. What is the need of algorithm design here? It is a closest design activity to a coding. If you want to implement the processing logic, how you are going to implement the processing logic? Based on the algorithm, should implement what to do, how to do, and what is the step-by-step process, right? For executing something. So for that, you should implement or you should design some algorithms. That algorithm activity is also almost near to a coding. Based on the algorithm only, we can develop some program. The program may be in any language. By seeing, or based on this particular algorithm only, we can implement the coding, isn't it? So that's why you should design some algorithms at this step. And also how you are going to design these algorithm, in the sense, first of all you need to describe the component, whatever you are designing for, which component function you are going to develop. First of all you need to describe the functions of that particular component, or designing of that particular component. And after that you need to go for refinement, step by step approach. What is the first step, what is the top level, what is the second level, what is the third level? So you need to elaborate the designing is called a refinement of a designing in the form of algorithm here, right? Next, use structured programming to implement the procedure logic. What you need to write here you need to go for a structured programming language. Okay, C is one of the structured programming language, or some other any other languages you may take at this step to implement the procedure logic here. And also if you need some mathematical functions, which is formal methods, to prove logic, then you may use in your algorithm, right? So this is all about a processing a logic. Why are we going for this processing of logic? To meet the function, to make the function at component level, all right? Next, this is the example for refinement, stepwise refinement. So what is Stepwise refinement. If you take one example, okay, that example is if you want to open a room door. This is the example for, okay, opening a okay, house door or otherwise one room door. So what is the steps you have? This is the first step. Step 2, walk to the door. You need to go to the door and hold the knob or reach the knob. Try to open the door through that particular knob and walk through the door, close the door. These are the 5 steps in level 2, right? If it is normal, the door is opened quickly and normally. If that door is little bit difficult, which means this process, then we are going for next level of, okay, uh, explanation or implementation. What is the next level? Okay, repeat until, I mean, rotate the knob clockwise, rotate the knob clockwise until the door opens. If if knob does not turn, then take key out, find correct key, insert in lock, then end if. Okay, here if that what key is not, whether check whatever the key you have used, that is correct key or not. If not, better to change the another key and try to open the door with that key, right? And after trying, either pull or push the door, move out of the door and end the repetition. This is the process. So like that, this is the refinement in the sense, okay, elaboration, step by step elaboration of a process here, right? Next, algorithm design model. Okay, in algorithm design model, represent the algorithm at level of details that can be viewed for the quality. So already we have seen in refinement, uh, algorithm refinement level. There we have seen level by level or step by step algorithm representation, isn't it? Here also you need to represent the algorithm at level of details that can be reviewed for quality. So how this algorithm, okay, here we are having some options for implementing a level by level. First one is there is a chance of taking the graphical representation. Graphical representation in the sense you may take flowchart representation or box diagram, and otherwise pseudocode representation. Pseudocode representation in the sense programming description language, and which kind of programming language you are going to take. After that, decision table here, right? These are the some algorithm design models implementation steps here. Okay, let us see one by one. First one is a structured programming language. Already this point you have seen in the algorithm design. The structured programming language, okay, uses a limited set of logical constructions. Limited set of logical constructions. Those are sequence or conditional or loops. In this structured programming language, you may use some logical construct. Logical construct in the sense you may use the general logical things or conditional or loops. Okay, conditional, under conditional you may get if conditions, cell conditions or switch case conditions, whatever, nested ifs, like that. Loops means while loop, do loop, repeated loops, repeated what structures you may use. And also these structured programming language leads to more readable and testable code. Okay, anyone can read easily and while testing it's very comfortable to everyone. And also it can be in conjunction with proof of correctness. It can be, okay, combined with conjunction with combined with a proof of correctness. Everything whatever we have implemented into this particular algorithm, it should be correct one. It should be a correct one, and it should produce a correct results. Okay, that is the process logic here, isn't it? If we implement one logic, if you write one logic there, okay, that should give the correct results to us. Otherwise, there is no use of that particular logic, right? And next one is important for achieving high quality, but not enough. Okay, these are all important to achieving the high quality. You may include many other things also, right? And here this is a structured procedural design. In this structured procedural design, same how we are going to implement. Here this is a either input. Here we are going to like a flow chart. How the flow chart will be executed. That is also a structured procedural design. Okay, it has some input functions, conditions. If it is true, it would be okay passed to, I mean, the outcome of this statement will be sent to some other route, or otherwise we may choose some other route to implement. If we'll take one example for a one example with flowchart means, already you know that designing of flowchart, how it is executed based on the conditions. Okay, for the given input, how it is processing based on the conditions, finally which kind of outcome it will give. So that like that the presentation is in that form. That form is also called as a flowchart architecture, or otherwise it's a structured procedural design here, right? And here one more small, here decision table. This is not a decision table. This decision table actually related to which kind of things we need to take, whether that particular problem accepts input or not. Okay, if it should accept input, so how many number of values we need to produce, what is the size of a one integer attribute. So like that we are going to, okay, um, develop the decision table, right? So this is not clear is here itself. Next we are going for a program design language. This is a PDL. So program design logic is a PDL. This is the structured programming language, and this is a PDL, right? What is the need of a PDL? Easy to combine with source code. Okay, this PDL is easy to combine with the source code, and also mission readable one, and no need of graphics input. Graphics can be generated from PDL. Okay, what is the graphics in the, here in the sense, just it's a conditions, like graphics in the sense here conditions based input is called the graphics here. Okay, PDL in the sense that is either in what normal language like algorithm representation, or otherwise sometimes it may be in the form of pseudocode. Pseudocode in the sense it's like a second generation language, right? So compared to a high level language, second generation language is little bit comfortable to a mission. Okay, and it enables declaration of data as well as procedures. So if we are passing if we are passing x, or if we are using a or b means, we need to pass the values for a and b. Okay, if it will be executed properly means we need to provide some data also to that particular procedures, and also easier to maintain, easier to maintain. This is about program design language. This program design language, suppose if you are developing this PDL for this particular what structured design, here we have this symbol. The symbol is represent a if condition. This if condition is true, then process A. If condition is false, then process B. At the end, you need to end the right. If you will take a general structure, a flow chart or structure, so for this flow chart, how we are going to implement the PDL? PDL in the sense it's like one algorithm, program design language, right? These are the benefits of that program design language. Clear? Right. uh, why this language already we have seen in above okay, that is about the designing of web applications. In next class we are going to discuss about component based development. Okay, thank you.